So my name is Abby Platt, and I am part of the Electrical Systems Technology program here at ACC. In this past summer, I was part of ACC's Solar or Harvest the Sun solar project, where I got the intimate knowledge on how to build a solar array. And if you drive down Woodward, you will be able to see ACC's solar array on the right-hand side. And that was our project this summer. And it's continuing until next August. But over the summer, I got the intimate knowledge that our community would benefit from a little bit more knowledge on solar energy. Hence my presentation. Throughout my presentation, I will answer 4 important questions. Why do consumers pick solar? How does solar work? What are some common myths surrounding solar? And what are the environmental benefits that come with solar? So there are 3 main consumer types that participate in solar. They're your farmers, they're your residential, and then they're commercial and industrial consumers. I want to start off with a question. How many of you buy your produce from a privately owned farm? Some of you, keep that in mind. So there are 3 main struggles that farmers face. So mainly it's the cost of essentials like fertilizer, fuel, equipment. This price keeps climbing, while crop prices swing unpredictably, making it harder and harder to plan and profit. Climate extremes are hitting harder than ever. So the hotter summers, the heavier storms, the longer droughts increase the risk of crop damage and often lead to costly repairs of equipment and facilities. Also, land pressure in changing markets are forcing tough decisions on many families who will feel pushed to sell or split up their farms rather than passing it down to the next generation. So solar provides long-term predictability. This means a stable revenue stream that farmers can count on. This stable revenue helps farmers pay off loans, replace aging equipment, and in many cases is the difference between whether or not they keep the farm or they sell it. So solar provides the revenue in multiple different avenues. Farmers can earn lease payments for hosting an array. They generate revenue through selling renewable energy certificates. And then they also, of course, save money through bill savings, all throughout keeping the land productive. Farmers can also participate in federal and state aid. This aid can often lower the upfront cost of solar with grants, tax credits, and loan guarantees. Make solar possible for smaller farms that might not be able to participate in solar. Next, I want to talk about residential solar. So residential solar is a little bit different because the solar that you make goes right into your house, right into the facility. This is different because other arrays, they just flow directly onto the grid. Meanwhile, your energy will go into your house rather than being pushed onto the grid. And this, in turn, reduces your monthly electric bill, increases the reliability during power outages, and also increases the household independence with things like batteries when rates and demand are high. Next, I want to talk about commercial and industrial companies. So this graph here shows solar production peaking at right around noon. This is important because typical commercial energy demand peaks at the same time. So when you go to work, this is usually the time when industrial machines are producing at maximum capacity. So by installing solar, companies can significantly cut operating costs by reducing the amount of electricity that they need to purchase from the grid. When solar is paired with energy storage, businesses can also take advantage of peak shaving, which helps lower demand charges by delivering some of the biggest cost savings to commercial and industrial companies. Along with the savings, C&Is participate in increased brand value. So it shows your customers and investors that the company is committed to your future, so the sustainability in clean energy and carbon reduction goals. Next, I want to talk about how solar works, mainly how you get power from solar. So I want to start off with what power is. So I want you to think about a water hose. So your flow rate is your electrical current, or your amps. Your water pressure is your voltage. And power is how much water is coming out of the spigot. Mathematically, we represent power as voltage times current. Now, in contrast, energy is how much water is in the bucket at the end of a period of time. Mathematically, we represent energy as power multiplied by time. Now that I've talked a little bit about power, I want to talk about the solar cells themselves. I'll use another analogy. So when I was a kid, I used to love the slide. And I'd have a friend with me. I wanted to go as fast as possible, so I'd have my friend push me down the slide. So in this analogy, sunlight is my friend. Sunlight pushes electrons down the wire. This electron movement is your electricity. And the movement in one direction down the wire is what we call direct current, or DC current. So I've talked a little bit about the solar cells. Now I want to talk about the arrays themselves. So solar panels are tilted and oriented to maximize the amount of energy they capture. Here in Michigan, that usually means arrays are facing south and oriented 45-degree angle, as geographically we are in the 45th parallel. So recently, there have been experiments with vertically facing panels to catch the morning and the evening rays. This, in turn, increases efficiency. There have also been technological advancements that increase efficiency with the use of bifacial panels. This means solar cells on the front and the back of the panels to catch any reflected light. And then also some arrays use tracking systems that track the movement of the sun throughout the day. So now that I've talked a little bit about how the solar arrays are engineered, I want to talk to you about the rows and rows and rows of panels that you might see. So one row here is what we call a string. And one string boosts your voltage. And now the strings connected in parallel boost your current. And a little while back, I talked about what voltage and current does, and it makes power. So that's how we get our power from a solar array. So shading analysis is also important. So in the lower right-hand corner, you see a little shadow on 4 of the panels on this one string. So I want you to think about the quote, "You're only as strong as your weakest link." This is apparent because even though the shadow covers 4 of these panels, it affects the entire string of panels because the inverter at the end of the string only optimizes at the lowest producing panel. So to avoid power losses, we would have to go trim that tree. Next, I talked a little bit about efficiency, but now I want to talk about what efficiency is. So efficiency is how much of the sun's energy the solar panel can convert into electricity. Ironically, most people assume that the colder temperatures in the panels is bad for efficiency, but it's actually the opposite. So solar panels tend to perform a little bit better when they're colder because electricity flows with less resistance or less heat. So the higher efficiency panels generate more electricity from the same amount of sunlight. This enables greater power production in the smaller area. leading to increased savings or more energy without expanding the system. So now that I've talked a little bit about the solar arrays itself, I want to talk about how solar is integrated onto the grid. So arrays produce direct current, or what we call DC current. And this is inverted into AC current, or alternating current, which is then transformed into high distribution or transmission voltage via a transformer. Now, a challenge with solar energy is that it does not produce reactive power. And this is important because it creates magnetic fields, your electric fields, which then are needed for things like motors or your transformers and the like. Grid operators also use reactive power to keep voltages steady and the systems reliable. Now that I've talked about the array itself, I want to talk about the 3 revenue streams that come with solar. So the most common revenue stream that people think of is your energy. This is where you'll get your majority of your revenue because it's directly tied with money. The next is capacity. So capacity is a little hard to explain, so I'll use another analogy. So I want you to think of a bakery. So capacity is kind of like an oven. So the bigger your oven, the more product you make. So your fossil fuel generation plants, these have the biggest ovens. They're 24/7 service. You're making bigger product, you're making more product because you have both the night shift and, say, the day shift. Your renewable energy plants are your mom and pop shops. They maybe work 12 hours a day and they have intermittent hours, but they're making little product. But on the other side, if you have more mom and pop shops, if you have more of the smaller guy, you will eventually be able to meet demand and make more product that matches your fossil fuel generation plants. It just depends on how many you have. And then the next revenue stream is your renewable energy certificates. So your renewable energy certificates, or what we call RECs, is the proof that renewable generation has occurred. This eventually turns environmental value into revenue. 1 megawatt hour of renewable energy is equal to 1 REC. And then companies and utilities buy these RECs to meet corporate demand or to say, hey, my energy is green. Now, to switch gears a little bit, I want to talk about the myths that surround solar, especially in the Alpena area and circulating online. So first, I want to talk about how farmers are abandoning agriculture. So I want you to remember what we talked about in the beginning, why farmers choose to participate in solar. They do it for the financial stability. They do it to continue to run the farm for the long term. And with smart land use, the land remains productive. Farmers can raise the arrays above the crops, allowing for dual use. This means solar production and crop production on the same acreage. They can also install panels on top of livestock facilities or raise them for shade for the grazing. And of course, cleaner energy means cleaner air. Next, I want to talk about how solar arrays are unreliable or they require lots of maintenance. So solar arrays are engineered for long-term use with very minimal upkeep. Solar panel replacement is rare because the panels are built to naturally withstand the environment conditions that they are installed in. Now, inverters have a lifespan of 15 to 25 years. This part replacement is considered a scheduled maintenance, not an emergency. But speaking of emergency, if the array does end up underperforming, the issues are caught quickly. with remote monitoring systems, which keep uptime high and the systems reliable. Next, I want to talk about how solar particulates pollute the land. When in reality, solar panels do not pollute the land during operation. So the panels are made of glass and silicone and are sealed and do not leak chemicals into the soil underneath. So the state of Michigan requires all generation plants to have a decommissioning plan for when the plant reaches end of life. And most solar components are recyclable. This means as more and more systems reach the end of life, the recycling industry will only grow. Next, I want to talk about how solar farms are ugly and then they can hurt my property value. Which is common to think this, but studies have shown that there is no conclusive evidence to support this. Developers have commonly used visual buffers like trees and hedges and fencing to hide the solar arrays away. But compared to your alternatives, your factories, your landfills, your housing developments, this is the quiet, low traffic, odorless alternative. Next, I want to talk about myth making. So some of the loudest objections are funded by big-backed oil campaigns that use fear and confusion to block solar initiatives. They amplify misrepresented data and outdated studies, often trying to delay and deny clean energy. This stall of timelines often delays landowners' money, as well as hands decision-making to anybody who shouts the loudest. We encourage everybody to check their sources and check the sources of their sources so we all get the right information. Last, but certainly not least, I want to talk about the environmental benefits, mainly where do all the emissions come from in the power industry. So fossil fuel carbon emissions, the majority of them happen at 3 stages: the fuel acquisition, the transportation of the fuel, and then the production and the generation stages of fossil fuel generation. This coal, gas, and oil released CO2 during mining and production, and far more when burned to make electricity. Reducing the reliance on combustion in ag generation stages is often an effective way to cut power sector carbon. Here are the typical CO2 footprints per kilowatt hour for fossil fuel generation. Keep in mind that these numbers do not include the manufacturing and construction of the plants and other necessities. Fossil fuel generation carries substantially more CO2 per kilowatt hour compared to renewable energies. Now, most renewable energy carbon emissions come from 3 stages: your manufacturing, your transportation, and your construction. That upfront cost is repaid quickly in avoided emissions because renewable generation is emission-free at the point of use. So even including manufacturing, renewables deliver lower carbon emissions per unit of electricity. Some other fossil fuel emissions include sulfur dioxide, nitrogen oxides, particulates, mercury, and more. Replacing fossil fuel generation with solar and wind reduces harmful air pollutants that affect the local and health ecosystems. Thank you. I'll take questions at the time. Yes.
Thank you, and if I were your teacher, you'd get an A.
Oh, thank you. Hear that?
No.
Yeah.
I don't know if this is a really silly question, but on cloudy days, is solar energy still generated?
Yeah, of course. Well, so the solar production is just a little bit less than on a sunny day. So that solar production, it's all intermittent. So when in reality, you're never gonna get as much as you're gonna get from a fossil fuel generation. But it is accounted for. So with like things like battery storage, intermittent cloudy days, you're just gonna use the solar batteries that are used.
Just percentage of it and not 100%.
So
Because you're still generating
Mhm.
your energy.
you're not generating at capacity.
Two unrelated questions. One, how, how do they keep the grass from growing around and up around the solar panels? I noticed the one that had
Mhm.
buffers of trees around it also has some getaway trees
Mhm.
that were growing up through the arrays.
Mhm.
How do they keep those areas trimmed back so that they don't interfere with the thing? And then the other unrelated, to what degree or percentage or however you put it, are the solar panels still made outside of the country?
Yeah. So for your first question, the question was how do they maintain the grass and the trees? So someone would have to maintain it. So someone would have to go out there and trim the grass. And actually, recently there have been a lot of places use goats, or I guess lambs, because goats jump on solar panels. So they use lambs. So so lambs and sheep for grazing. So they graze underneath the solar panels, and yeah. So I found that really cool. We actually went up to the UP and we saw some lamb or sheep and lambs up there in their solar array. I was like, that's really cool. We should do that in ours. For your other question, it was yeah. I'll refer to my instructor here.
All right, so, I'll just introduce myself a bit. My name is Wesley Repke. I'm the former director of engineering, for Prescott Electric and Gas, and, I hold a bachelor's degree in computer and electric engineering, master's certificate in advanced energy, which includes, renewable energy. And I'm currently pursuing my full master's degree while I'm, teaching Port Abbey here. So, when it comes to panels in the United States, we do have a lot of places that manufacture them, but they're generally smaller operations. The quality of their panels are not that great. That's not always true. And of course, you're going to find a couple offshoots here and there that produce high quality panels. But we have found that a lot of them over time go out of business because it's very difficult for renewable energy startups, especially panel production, to be successful. So the majority of panels have come from, say, China, or one of the better ones that was used frequently in the United States was Canadian solar. Although right now with tariffs, that's becoming an issue to acquire those panels as well. In fact, Canadian solar was one of the larger ones for some of the larger producers in the area. I can't remember for the panels for our rate. They were, yeah, ours
Yeah,
were
Canadian Solar.
The one benefit we had with ACC's array is all the panels had already been purchased by the installer. So they didn't have to pay tariffs on the panels we put into ACC's array because they were already in a warehouse. I do think that with the tariffs coming into play, we're probably going to see more players come online, though. I think that would be the most accurate way to describe it at this point in time. But if you really want me to get down to the bare tax of this, I'd have to have some time to actually look into it in a little more detail.
Mhm.
So I could probably send Abby on. Yeah.
Yeah.
Right.
Yes.
Are they just silicon conductors or are they building all of in there?
So doping,
You can answer this one.
it was doping. I just learned this actually. There was the N junction and the P junction, which was, I think, gallium arsenide, and germanium. I think those are
There's also just pure silicon.
pure silicon. Yep.
The thing that we're getting at is that semiconductors in solar cells are doped, which doping is a process of semiconductors where you introduce an impurity, okay? And that causes some of the materials to have either more electrons than they normally would for that particular element, or to have fewer electrons. And in the material science industry, we call that holes. Okay, so the absence of an electron would be a hole.
Mhm.
And when you pair different types of these materials next to each other, you'll have a p-doped material, a positively doped material, which has holes, and an n-doped material or a negatively charged material. They create a semiconductor junction called a PN junction. And that's what all diodes are. And then every diode is then optimized for a particular use. And in the case of a solar array, we have a photoelectric diode. Okay. These are the type that specifically will receive light and then push electrons through, just like Abby's slide metaphor had suggested.
Yeah.
So it was a very accurate way to describe what happens. Whether the sun hits into the solar junction, the PN junction, and pushes electrons through.
We're using visible light. Are we only using one wavelength?
No. In fact, a good chunk of the light isn't visible light that is collected by solar rays. A lot of it does lie on the infrared spectrum.
That's what I was asking.
Yep.
Many years ago, it was all visible light.
Mhm.
The holy grail was to get, if you get two wavelengths, it work double the number of electrons.
Mhm.
You are referring to, do you remember what this is from class?
Multi-junction cells.
Multi-junction cells. So some of the older solar panels were single junction, which means they only had one PN junction in them. Now they're stacked with multiple layers. They have multiple junctions, so you can collect multiple wavelengths of light. Because you are correct, each junction is tuned to a particular range of light.
You had a question?
When you go like holes in there,
Mhm.
you got acres and acres of that solar panels there.
Mhm.
Where is that energy going to and how does it get there?
So solar arrays are integrated onto the grid. It just depends on what what the utility, you might,
I
do
do.
you know?
I
He knows.
I'm still looking at pi and z when.
Yeah.
So that entire array was commissioned by DTE Energy. So not a single electron is going to northeastern Michigan.
Oh, okay.
It is all being pushed onto a separate dedicated collection grid on the distribution level. It is then going to the transmission lines that are immediately pumping it downstate. So that's actually one of the big
Mhm.
reasons why it's caused so much controversy is locally up here, we aren't benefiting from it.
Yeah. Yes.
Or is it the array produced? And what's the other question? I forgot.
1.8.
Yes.
1.8.
Yes.
1.8 megawatts. Mhm.
Which means what? That means ACC only using the solar power? Or-
No. So actually, ACC has been working with Alpena Power to directly put it onto the grid. So it will benefit the community.
It'll come up a line along Woodward, and predominantly it'll probably feed into ACC and Besser and probably the hospital, kind of that general area. But with how much it's producing versus how much all those areas use, it'll be used up relatively quickly.
And what I was going to ask, the efficiency.
Mhm.
The efficiency was first developed 50 years ago. The efficiency was 1, 2, 3%. Where do you have to?
You remember?
I think it was 8, wasn't it? 8%?
Oh, no, it's a
No.
lot more than that. So as of about 10 years ago, I want to say it was about 15-16%.
Oh, yes.
Right now, commercially available panels are probably on the order of 21 to 23%. If you go onto the NREL website, that's the National Renewable Energy Laboratory site, you'll find panels in experimental situations that can get up to as high as 46%. But these are very, very specific circumstances, and we are having extreme difficulty manufacturing cells with consistency to retrieve energy at that level.
What was that partly because you're using multiple junctions and multiple wavelengths?
That is part of it. The other thing, some experimentation has been with specific materials that break down during manufacturing, or they're very, very fragile. So using them in an industrial environment to put the cells together is very, very challenging.
Question. What, you had said the inverters have a replacement schedule for about every 15 years. How long does a panel last?
So panels,
Or are they connected?
they start degrading. Their efficiency goes down at like when it starts to use. So I think it's 40 years.
Indefinitely, technically, but at about 30, 40
30,
years.
yeah.
That's when you really want to seriously consider replacing them.
Mhm.
Sometimes they'll go on a rotation schedule of 20
Yeah.
to 30 years as well, because you can do, what harvest solar call it again, where they flip the panels out, they pull out the old ones, put new ones in.
Oh, what they called
I
it.
think it's called recommissioning is the process.
Oh.
Where a solar array that when it comes to end of life, you have two choices, either decommission it, remove it,
Oh,
or you
yeah.
recommission it and basically remove all the old panels and put new panels on. And a lot of times they're choosing to recommission them.
So just one other question. It's weather related. Do they get hit by electricity or not electricity for God's sakes?
Lightning? I mean, I think it's like the same as your house, like does your house get hit by lightning? I mean, I think there's safety measures, so lightning rods and stuff like that are used to divert the lightning, but yeah, so.
And I think you had presented at a college board meeting, kind of a little about your experience.
Yeah.
Can you talk about what it looked like when you got here and then what agencies or companies you worked with to get it where it is today?
Yeah. So around June, I guess, June, I was brought on as an intern. No, wait, it was December, last December.
I would say it was November of last year when you and Alec both.
November. Yeah, November. So, okay. So the ACC had applied for a grant to build the array. And so they put out an RFP for contractors. And so I was actually part of the contracting board, I guess. So we got to, I think there was 5 contractors that bid on our RFP. And we, in a matrix style, we graded the contractors' our bids, and we chose Harvest Solar as our contractor. And we started. It's been so long.
I felt it. That's actually the first time.
Yeah,
to the board.
Yeah, so we presented our decision to the board, and then come June, we were in meetings with Harvest Solar and Alpina Power to officially start construction. So,
Who are some of the other entities you had to work with? Did you have to work with the city at all? Whatever.
I mean, we worked a little bit with the city to develop their solar regulations. Because Alpina, as far as I know, has very little on solar arrays. So we have been working with them to create those for the future. We had to call out for contractors for land preparation. So we did, I mean, if you ever been down Woodward, it's all rock. So the vegetation wasn't very, I guess, high. There was just really long grass that we needed to have people come out and do. I think ACC actually ended up having just their maintenance staff go out there and prep for the array. But we had to call out for equipment for a brush hog. So equipment.
Also had to deal with the parking lot staging.
Oh yes, we had to work with Elmer's and Huron Engineering for staking of the array, and then come, was it September? Or August, or no, September 8th, I think. They
Yeah.
actually started construction, and they were able to construct the array in like a month, I think.
What's special about this array considering the ground conditions? What did we have to do before we could start construction?
We had to do pre-drilling. So because the ground is basically bedrock, they had to have a company, APA Solar, I think, had to come out and pre-drill into the bedrock with a hydraulic drill, so we could actually get the supports up that we needed to.
Large producers of energy, like consumer power, can they compete with fossil fuels or nuclear? And would you be moving towards some?
I would say if you want me to take this one, because
You repeat his question, so.
I'm pretty sure that they can hear me here.
Yeah.
I'm hoping for the recording. So his question was, can places like consumers, can they basically convert over to solar in a way that would be meaningful and completely replace fossil fuels? Is that the gist of your question? Yeah, and nuclear. I would say that from an engineering standpoint, the answer is yes, but it comes with caveats. The speed at which you do it is going to determine how expensive it is. And right now we have a huge problem where the cost of energy, along with everything else, is increasing. It feels exponentially. So there's probably not a lot of appetite to convert like that. If we did that, it would be very, very expensive. The other issue we have is energy storage. Right now, renewables, which is kind of what Eddie was getting to with her bakery comparison, is renewables are intermittent. Okay. That means we have a difficult time producing energy, say at night, or maybe through the winter because the days are shorter. We have less energy available from the sun directly. So there are challenges. It's not that they're unsurmountable or that we couldn't get through them, but they do cost a lot of money right now. Energy storage costs are coming down when you come to different battery technologies. And one of the first arrays that was deployed with solar and energy storage in Germany happened over the past 2 years, I believe. And they were able to deploy that array with energy storage at a markedly viable price. What that means is you now have a solar energy producer that can now compete on the energy market with 24/7 power, and it's at a comparable price. That was the first one. So if they have one, there's a good chance that we're going to see more of those pop up. Now, addressing nuclear specifically, I'm personally a pro-nuclear person because I understand base load and I understand how much is out there, and I understand that nuclear is carbon free. Not everybody in the green community believes that. Not everybody believes in nuclear is what I'm trying to get at, because there are the issues when it comes to the waste. What do you do with it? Right now in the nuclear side, all of the waste that's been produced historically from all the power plants in the United States is still currently on site at those power plants. Okay. So arguably, they have successfully stored it where it's been used. If you want to go take a step that's even more advanced, there's 2 types of nuclear reactors out there. And three types of nuclear reactors out there. So there's 2 types of nuclear fission reactors. Back in the 1950s and 60s, when the United States and other countries started developing nuclear, we developed a type of nuclear reactor that basically takes the nuclear fuel, runs it through the reactor, spits it out, and it's waste and it can't be reused. Okay. There is a different type of nuclear reactor that we were experimenting with at the same time, but the development was later and it didn't take off because we had already invested so much in the first reactor type that it just didn't go anywhere. But that other reactor takes nuclear inputs like uranium or plutonium, takes in the reactor, recycles some of it, or actually the vast majority of it, with a little new injection and keeps recycling it for about 4 or 5 times. So the amount of waste when it comes out is dramatically reduced and considerably less radioactive. Okay, if we were to implement nuclear generating stations with that technology, we could actually use up the waste on site at nuclear reactors so that we reduce it. And it's fuel. We can actually use the waste as fuel to help generate more electricity. I personally view nuclear energy as one of the most advanced pieces of technology that human civilization has ever developed. The fact that we aren't leveraging it as much as we could be, I find to be a bit sad. We do have to understand the issues with it, though, because the issues are very severe. We should not be building nuclear reactors on fault lines. Japan. Just saying, that is probably not a smart decision. But if you're getting out to a place where, you can have relatively good control over, say, the geography, nice flat plain, and you know that you can do certain control measures to prevent weather from causing issues. And we also have really safe reactors in the United States. Our reactors are meant to fail safe, whereas, say, Russian designs, not so much. There's a reason why 3 Mile Island did not explode like Chernobyl. It's because our reactors are designed better than Russian reactors. Fukushima, I don't know as much about, even though that was a more recent one, but I know that there was some issues with radiation being released in that sense. Does that answer your question?
Good.
Great. So maybe too many details, but
You mentioned about fitting it onto the grid, and are you producing 3 phase, going on the grid as 3 phase?
Yeah. So, so right now, power companies have their grid is, I guess, engineered for their load right now or their generation right now. So if you add more generation onto the line, you have to be able to upgrade the lines to make it safe, so we don't have any failures or anything. So that is important, and that's kind of what I mean by fitting the power onto the grid. What was the other question? It was, yeah. So yes, the answer would be yes. Yes. Yeah. The only challenge with renewable energy is that it doesn't really produce reactive power, which we get from fossil fuel generation. Reactive power is kind of like imaginary power. It's what makes your motors run. What's make transformers run.
this is so I actually directed Abby not to get too technical with us because I wanted to make sure that this presentation was accessible to a wide number of people. And I wasn't sure how many of you guys would like to see very long calculations. So reactive power, this is one of the things that is one of the most important things when you go into the power industry, you become an electrical engineer, is understanding 3-phase power and reactive power. It is one of the hardest concepts because it is represented with imaginary numbers, but it is not imaginary, okay? Reactive power is in some respects wasted energy, but not really. It is when I go into a motor and I'm trying to get it to generate and turn and run, what happens is I create a magnetic field in a part of the motor called the stator. And that transmits an electromagnetic field to the rotor, okay? Once the rotor receives that electromagnetic field, it kind of develops its own internal current that starts flowing, and that creates what's referred to as an electromotive force, okay? And the rotor starts spinning. In order to get that electromagnetic field to jump from the stator to the rotor, that is what creates reactive power. You need this reactive power in order to do that. Otherwise, it's kind of like what creates the electromagnetic field in the first place. And it's generally created by a rotating piece on a generator that then transmits it to a stator that creates electricity that flows down the line. So you have these reserves of reactive power in your generator because of the rotating mass. Okay, and that will then transmit it down the lines so that you can then receive it and use it in your three-phase AC power for other devices. Okay, the problem with DC power generation is that it is all real power and it doesn't create that reactive power component, not natively. There are ways to kind of, I guess, fake create it, but they involve adding cost to the way that it would be generated. So.
I'm so glad to hear you made a engineering
Actually, I'm pretty sure you're. Yeah. She was my pre-calc teacher, so, and I see her and a couple of you guys around at trivia here at Latitudes, which I'll probably see you guys there tonight for the dinner. So.
But where is this used in the real world? And I struggled with where are engineering numbers used in the real world? And I told students, I know it's used with electricity, and that's all I know. So I was glad to hear that that really is true. But Abby, can you tell us what's your experience been like at ACC? Have you been involved in any clubs or sports?
Oh boy, that's a long list.
I might want to stop.
Yeah. So I came to ACC in 2022. So I was on the ACC softball team. I've been on the ACC's basketball team. I'm on the ACC soccer team. I was part of the student leadership last year. I'm part of RISE, the new RISE group around campus. I am currently a resident assistant at CPA. Oh boy, I don't really have enough time. I was an intern last summer. So that's my extracurriculars. So I've been here for a while and I really enjoy it. I personally, I love the smaller class sizes. Right now it's actually just me and Wesley in some of my classes. So, you know, I really enjoy it here in Alpena. So, did that answer your question? Okay.
So what's next?
So what's next? I actually did apply to Alpena Power, so I will be working there after graduation. Thank you.
Lafarge, do you know anything about their?
I
On the planning commission for Alpena Township, we approved them. There. Do you have do you know how does our array compare the size of theirs? Do you know anything about theirs or?
Very little. We did use the same company as theirs. In fact, that's one of the reasons we had to get special quoting for the drilling, because we knew we were going to be on the rocks. As far as the size of their array, we'd have to talk to Harvest Solar. I guess it would depend on if you were to come in some official capacity with the township. I'm sure we could probably get you in contact with the right people. So if you want to get our contact information afterwards.
Yeah, no, I was just kind of interested whether you guys had anything.
Not off the top of my head.
No.
There,
Yeah, that was a whole separate project, and
well, I understand that. Yeah.
I know it's a little similar because with the drilling and stuff, but not any specific details.
Oh, we're good.
Yes.
See if anyone has questions or comments online, why don't you unmute your microphone and go ahead and ask the question.
I actually do have a question, Abigail.
Thank you.
My favorite. Sorry, I'm mom.
She's my mother. She's my mother. For context, she's my mother.
I am. But you did such a great job. But my question is, how will the solar panels affect like electric vehicles, and how many would it take to power an electric vehicle or keep the electric vehicle industry kind of a viable option?
So that's a good question. It's a long answer though, because electric vehicles are
the quick version.
Well, I might have to refer to Wesley, but electric vehicles are they're not a problem on the grid, but it's a trouble getting like the power stations, it's kind of hard to.
I'll take it here. I just
Okay.
had to. So our array, our 1.8 megawatt array, if we were to charge each vehicle at about 20 kilowatts, we could charge 90 vehicles simultaneously. So, and what Abby's trying to get to here is something we've discussed in our classes when it comes to whether or not electric vehicles are a huge problem, as far as the amount of demand. Again, this comes to a time thing and how quickly things are adopted. If they're just being adopted at the rate they're currently being adopted at, it probably won't be that big of an issue. The bigger issue right now we're finding on the grid is data centers. And I have personal experience with this because at ING, before I left, we had one data center that wanted to move to Northern Michigan, and they wanted to consume approximately 260 megawatts of energy. And just so we're clear, the entirety of Presqu'île Electric and Gas's grid consumes about 60 megawatts.
Oh my gosh.
Yes. Whereas in order to get up to the same amount of energy for electric vehicles, you're talking hundreds of electric vehicles. So my concern has been in the power industry is more data centers, because everyone wants to do AI now, AI this, AI that. They want to do Amazon shipping center this and Amazon shipping center that, and it all requires this computing capacity from data centers. And we straight up do not have the electric capacity to bring those online. Electric vehicles, not as big of an issue as data centers. So.
Very good to know. Thank you very much.
Thanks, Mom.
Can you feel the love?
Do you have any more online?
They're free to.
Okay.
People online, you're free to open your mic anytime you'd like.
You did great.
We think so too.
Yes. I'm very proud.
There are no more questions and our time is almost up. If you do have one of those long formula questions or you're really interested in that, hang out here. Otherwise, you are free to go, and thank you so much very much.
Thank you.